Today we will be discussing how to graph inequalities. We've graphed equalities or equations before, but now we are going to be discussing how to graph inequalities. So in the form of less than or greater than. So when we graph an inequality, or when we graph anything, any equation, we divide our coordinate plane into three distinct groups. The line that we graph, the points on one side of the line, and the graph on the other side, or the points on the other side of the line. So let me give you an example. So say we have the equation y equals x plus 2. I'm going to graph that. This is in y equals mx plus b, slope-intercept form. So our y-intercept is at 2, and we have a slope of 1. So up 1 over 1, up 1 over 1. And then if we use a straight edge, okay, and there is our line that we just graphed. So as I said before, now we have three distinct sets of points. We have all the points that lie on this line. We have all the points that are on this side of the line. And then we have all of the points that are on this side of the line. And when we have an inequality, we could have the same looking equation, but as soon as we put a less than or greater than in there, then that tells us that that's a whole new set of points. So the first thing we are going to do to learn how to do this is that when we have this line, we are then going to see, we look at the points. Let's just say we have the point 0, 0. Okay, 0, 0. If we were to put that into our original equation, the 0 and the 0, I get 0 equals 0 plus 2. So 0 equals 2. Now that doesn't make much sense. 0 does not equal 2. Right. So this is our y value. Our y value is less than this. So this would be the area of the graph that is y is less than x plus 2. If I were to put in, say, the point 0, 3 right up here, it's on this side of the line. If I were to do that, my y is 3 and my x is 0, so 3 equals 2. That doesn't make sense. But this y value is greater than 2. So that would be y is greater than x plus 2. Let's kind of take this apart a little bit. Okay. So I want to graph the inequality y is greater than negative 2x plus 3. So the first thing we are going to do is we are going to graph the equation y equals negative 2x plus 3. So we're going to first find our y-intercept, which is at 3, and then our slope, our m is negative 2. So we're going to go down 2 over 1, down 2 over 1, down 2 over 1. Now we can see our line starting to take shape. Now, instead of just drawing that line in there, we have to look now at our actual inequality. Since this is just greater than, so if you have greater than or less than, not greater than or equal to, less than or equal to, but just greater than or less than, we graph this line with a dashed line. So I am making a dashed line. Okay. That means any point on this line is not going to make this inequality correct. If I were to choose one, let's just pretend, just to show you, I'm going to put the point 0, 3. That is on this. So if I put the point 0, 3 in there, I'm going to put in here the y is the 3 greater than negative 2 times 0 plus 3. So I whittle this down to 3 is greater than 3. Well, that is obviously false. That does not make sense whatsoever. So that's why we have that dashed line. But now what we do, we pick a point on one side of the line and So anything over here or over here, and we see if it makes sense. If it makes this original inequality true, then we know we've got the right side. So I'm going to show you what happens. I love, if I possibly can, pick the point 0, 0. Unless it falls on that line, I will choose that every single time. And here's why. I'm going to take my original inequality, and I will now substitute 0, 0 in there. So I'll put 0 in for y, negative 2 times 0 plus 3. And I'm going to put a little question mark over that greater than sign. Is 0 greater than negative 2 times 0 plus 3? Well, we know this drops off. So now we're going to say, is 0 greater than 3? The answer is no. So that means the points over here don't work in this inequality, but the points over here do. So all of these points over on that side of the graph work for this inequality. Let's choose one just to be sure. I am going to choose the point 4, 0. So if I chose the point 4, 0, I am going to keep my original inequality and plug in. So my x value is the 4 and my y value is 0. So I'm going to say, is 0 greater than, there's my little question mark, negative 2 times 4 plus 3. So negative 2 times 4 is negative 8 plus 3, and now we have to add our integers. Is 0 greater than negative 5? Yes. So therefore, that means everything over here is a solution. Let's do another one. We are going to graph y is less than or equal to x plus 1. So we are first going to graph the line y equals x plus 1. So we're just going to change that to an equals just to get that line going. So here is our y-intercept. It's at 1. And then our slope is 1. So up 1 over 1, up 1 over 1. We see the line start to take shape. Now, since this is less than or equal to, the or equal to means we have a solid line when we graph this, because everything on this line will make this true. So if we do not have an or equal to here, we're dashed. If we have or equal to, we have solid. Now we are going to pick a point not on the line, so on one side of the line or the other, pick a point, and we are going to see if that we've chosen the correct side. So let's because I love the point 0, 0, I'm going to put that in. So I am going to start with my original inequality, y equals less than or equal to x plus 1. I am going to plug in the appropriate values, and I'm going to ask myself, is that true? Is 0 less than or equal to 1? Yes. So that means the side that contains the point that I selected is the side that I shade in. So every point on this side of the line, and including that line, will be a solution for that inequality.